In this video, I'm going to go over B and D for number 4 in 8.5 or 3.5, depending on your class. You're going to hear baby in the background. So the first thing we're looking at is the constant term. Now, we need to know what a constant term is. A constant term is just where it has a constant. So, in this quadratic, this is the constant term. So you can think about it as, well, it has x to the 0 power. So, is there ever going to be a time where I have these terms to get them to be to the 0 power? Now, I need to remember that they're going to be raised to the 45th, and that can be split between them. So I'm going to have x to some number. So, I don't know, we'll just do r. And then negative 2 over x to 45 minus r. Whatever those are going to be. Now, I don't really care about the number because I just care to see if we're going to have one. So I'm going to pretend like it's 1. So basically what you're doing is you're going to take xr times 1 to the, whatever this is still going to be 1 over x to the 45 minus r. Well, I can separate those if I think about my exponents. So if you think about exponents, you've got x to the 4th divided by x to the 1st. Well, how do you get x to the 3rd? You subtract them. So if I switched it and said this was now to the 6th, you would subtract them and do 6 minus 4. So I can really move this up. So I'm going to have x to the 2r over x to the 45th. And then I'm going to write this as x to the 2r minus 45 because I can just subtract that. So what I'm really trying to see is, does that ever give me x to the 0 power? So does 2r minus 45 ever equal 0? Well, when r is 45 halves. So if I let my exponent be 45 halves, I should get an answer. But we don't let the exponents be half numbers. They have to be whole numbers. So we can't do that. Now, if we didn't want to go that very exponent-y rule, you could also look at the first 3 terms. What's happening to the exponents is they're decreasing by 2. They're hitting all the odd numbers. So I would have an x to the first term, and I'd have an x to the -1 term. I'm not going to have an x to the 0 term. So you could just look off of the patterns as well. Okay, so no constant term. Either the pattern, or you could say I don't know, that it would have to be a half number. I don't know, just something like that. Okay, so then part D, let me get the, move this over. I'm going to look for the x cubed term. Now I am going to have an x cubed term. It's going to be right before the x to the first term. So I need to figure out where this thing right here is going to be x cubed. So I could go through this whole process again and say, okay, I'm going to have x to something and then 45 minus that something. And now I need it to equal 3 instead of 0. D. So where does 2r minus 45 equal 3? I don't think this is the way I solved it on the thing. I don't remember what I did on the thing. Okay, so if I add 45 to both sides, I get 2r is equal to 48 and divide by 2, so I get 24. So I want this piece to be 24. So I'm going to have 45, some number, x to the 24th, which means I'm going to have negative 2 over x to the, well, what's 45 minus 24? It's 21. Okay, and that's going to be the one that matches down here. So then I figure this out. So I have 45, math, go over to probabilities, oops, too far, and then it's 21. So a really small number, or I mean a really big number. Oh, what was it even asking? I don't think that's what it was asking. I think I wrote it down wrong. Find the term containing if it exists or justify why it doesn't or does not. Okay, so I mean, I'm just going to keep this because it's a really small number or big number. Of that. And then I'm going to take 24 and then negative 2 to the 21st. It's going to be a negative 2 to the 21st over x to the 21st. X to the 24th divided by x to the 21st is going to be 3. So I have this negative 45 21st times 2 to the 21st times x cubed. And that is the number, well, the term. So yeah,